Bismillahirrahmanirrahim. Assalamu alaikum, boys and girls. Welcome back to another new lesson of distance learning program. Dear students, as you all know, my name is Sayyid Faraz Hassan and I am your mathematics instructor. With me, I have my team, the team of subject specialists, Sir Ashraf Ali and Ms. Shabana Salman. Dear students, today we will be discussing, we will be starting a new chapter. This is chapter number 12 of your maths book 3, the area and the volume of similar figure and solids. In the first exercise, that is 12a, we will be learning how to find unknown area and a side from given pair of similar figures. And in the next exercise 12b, we will be learning about volumes and other unknown lengths. So let's start the first exercise, boys and girls. Uh, this is the learning objective for this. By the end of this lesson, you will be able to find the area and the unknown side of similar figures. Now, uh, in this, in every question, you will be dealing with a pair of similar figures. Now, the figure may be a triangle, they may be rectangle, they may be rhombus, they may be trapezium, but they will be similar figures. What you need to do, you need to apply a formula to find out the unknowns. Now, what is that formula that you will be using in this exercise? That is the ratio of areas of the two similar figures is equal to the square of the length of ratios of similar figures. I'm repeating it once again. The ratio of areas of two similar figures is equals to the square of the ratio of their corresponding sides or lengths. Uh, Mathematically, I can express this as the ratio of the areas, that is A1 upon A2, is equal to the square of the ratio of their corresponding lengths. That is A1 upon A2 is equals to L1 upon L2, the whole square. Okay, how are we going to read it? The ratio of areas is equal to the square of the ratio of their corresponding length, that is L1 and L2 whole square. So this is the formula which you will be using in the entire exercise. So let's start exercise 12a. This is on page number 393 of your maths book 3. Question number 1. Find the unknown area of each of the following pairs of similar figures. The first one has been done for you as an example. So if you can see, there are two triangles given to you. The area of the first triangle A1 is equals to 4 centimeters square, and the one of the length of the first triangle is given to you. L1 is equals to 3 centimeters. Likewise, uh, for the other triangle, the area A2 is unknown and the length L2 is given to you as 4.5 centimeters. Now, what you need to understand in this, you need to have the corresponding length L1 with the area A1. Okay? You're going to pair up A1 and L1 and you're going to pair up A2 and L2. So this is the formula which you can see. A1 upon A2 or A2 upon A1 is equals to L2 upon L1 the whole square. So in this formula, you're going to plug in these values which is given to you in the question. A2 is unknown, so it's unknown there. A1 is given to you as 4, so A2 upon 4 is equals to the length L2 is 4.5, so I've written 4.5 there. upon L1 is 3, 4.5 upon 3, the whole square. Now you can simplify it. You can simplify it either by using your calculator, or you can remove the decimal by multiplying 10 numerator and denominator. So, or if you don't want to remove the decimal, you can use 1.5 times table, right? 1.5 twos are and 1.5 threes are. Now, 3 square is 9, 2 square is 4. Now you have a 2 upon 4 is equals to 9 upon 4. In the next step, what you can do, you can cross multiply this 4 over there, 9 upon 4 multiply by 4. Now you have 4 in numerator, 4 in denominator. You can cut these out. So you are left out with only 9 on the right hand side. Therefore, the unknown area A2 is equals to 9 centimeters square. I hope this makes sense. Let's do one more question, and inshallah your concept will get more clear. So this is it. So again, there are two triangles given, and it's a pair of similar figures. They have shown you some internal angles marked with double curves and single curve. It shows you that these are similar figures. Now, the area of the first triangle A1 is given to you as 64 centimeters. So let me write the data for you guys. A1 is equals to 64 centimeters square. The corresponding length L1 is given to you as 8 centimeters. Likewise, the area A2 of the second figure is unknown, question mark. The corresponding length L2 is given to you as 2 centimeters. So what is the formula, boys and girls? The ratio of areas of the two similar figures is equal to the square of the ratios of their corresponding lengths, right? So this is the formula. Ratio of areas A1 upon A2 is equal to the square of the ratio of their corresponding lengths. This is the formula. A1 upon A2 is equals to L1 upon L2, the whole square. Now, boys and girls, you're going to plug in these values which are given to you in the question. A1 is 64, A2 is unknown, is equals to L1 is 8 and L2 is 2, and there is whole square on it. You can simplify it. 2 ones are 2, 2 fours are 8, so 64 upon A2 equals to the square of 4, 4 fours are 16, upon the square of 1 is 1. Again, you can cross multiply it, A2 on the other side. So you have 64 is equals to 16 A2. Now, what is unknown, boys and girls? A2 is unknown. So bring 16, cross multiply 16 on the other side. So now you have 64 upon 16 is equals to A2. So 16 ones are 16, 16 twos are 32, 16 threes are 48, and 16 fours are 64. So your required area of the required unknown area of the second triangle A2 is equals to 4 centimeters square. I hope this makes sense to everyone. What we have used, we have just used the formula, that is the ratio of the areas is equal to the square of the ratio of their corresponding lengths L1 upon L2 the whole square, or you can simply learn it as A1 upon A2 is equals to L1 upon L2 the whole square. So after writing the formula, you need to plug in these values which are given to you. and you need to simplify it by cross multiplying the numbers on either sides. You found A2 is equals to 4 centimeters. I hope this makes sense. Let's move on to the next question, boys and girls. All right, boys and girls, this is another question. They have given you two cones, and they have given you the surface areas as A1 and A2, and their round circumference as 4 centimeters and 6 meters. Now, you know that the circumference, that is the perimeter, the round perimeter, is also a kind of length. That is why it is it is expressed in meters and meters, 4 meters and 6 meters. So this round bottom circumference is also a kind of length, and they have given you the paper area A1 and A2. So what are you going to do? You need to write down that formula again. That was A1 upon A2 equals to L1 upon L2 the whole square. Noted that the L1 in this case is the circumference 4, and L2 in this case is the circumference 6 meters. So A1 upon A2 is equals to L1 upon L2 the whole square. Now after this, we need to plug in these values which are given to you. A1 is 12, A2 is unknown, is equals to L1 is 4 and L2 is 6 the whole square. Now you can simplify this. 2 2s are 4, 2 3s are 6. So finally you can simplify it. 12 upon A2 equals, the square of 2 is 4 and the square of 3 is 9. So boys and girls, you can cross multiply. 12 multiplied by 9 is equals to 4 multiplied by A2. Now what is unknown? Area A2 is unknown. You can cross multiply this 4 downwards. 12 into 9 upon 4 equals A2. So 4 ones are 4, 4 threes are 12, and 3 nines are 27. Therefore, the unknown area A2 is 3 nines are 27 meters square. I hope this makes sense to you guys. Okay, what we have done, we have applied the formula A1 upon A2 is equals to L1 upon L2 the whole square. A1 is given to you as 12, A2 is not given to you. The bottom circumference, the round length of the first cone is 4 meters, the second cone is 6 meters, so I have considered it as L1 and L2. Plug in these values, simplify it by cross multiplying the denominators on the other side, and I found that A2 is equals to 27 meters square. So another question, boys and girls, there are again two triangles given to you. Now, the first area A1 is 10 centimeters square. The second area A2 is 90 centimeters square. The first length L1 is 5 centimeters and the second length L2 is B, that is unknown B centimeters. So this is your A1, this is your L1, likewise this is your A2, and this is your L2. So dear students, what is the formula we have learned? A1 upon A2 equals square of the ratio of their corresponding lengths, right? So let's plug in these values. A1 is 10, A2 is 90, okay, L1 is 5, and L2 is unknown letter B, whole square. Now, what can you do? You can simplify it, the left hand side, by eliminating zeros. Zero cancel with 0. Now I have 1 upon 9 equals 5 I can open up these bracket. 5 5s are 25, or no need of opening, no need of opening it at all. You can simply do it 5 upon b whole square. Now, I can see on the right hand side there is a square, and on the left hand side 1 upon 9 is also a square of 1 and 3. The square of 1 is 1 and the square of 3 is 9. So I can see the two squares on the two sides of this equation. In order to get rid of this square, I'm going to take square roots on both sides. Taking square roots both sides. Now listen to me, boys and girls. You don't need to write these statements. I'm just writing this to make you understand. Okay, what am I doing? So 1 over 9 equals 5 over b whole square. Let's take square root on these two sides. So I have square cancel, square cancel. The square root of 1 is 1. The square root of 9 is 3. So I'm left out with 5 over b. Now what was unknown? B is unknown. Cross multiply the two denominators on the other sides. B is equals to, or 1b is equals to 5 multiplied by 3. Finally, I found that b is equals to 5 threes are 15 centimeters. So by using the same formula, the ratio of areas of the is equals to the ratio, the square of the ratio of their corresponding lengths. So by applying the same formula, I found the unknown length b of this, and it is found to be 15 centimeters. Let's move on to the next question now. Now, boys and girls, another question. Now, they have given you two leaves, right? The area of the first leaf A1 is equal to 27 centimeters square, and the area of the second leaf, the small one, is 12 centimeters square. The length of the first leaf L1 is 6 centimeters, and the length of the second leaf L2 is d centimeters. Find the unknown. What unknown can you see in this? You can see the unknown length L2. So again, using the same formula, the ratio of areas is equal to square of the ratio of their corresponding lengths of the similar figures. So the corresponding lengths will be L1 upon L2. So let's plug in these values. A1 is 27, A2 is 12, L1 is 6, and L2 is D, the whole square. So you can use 3 times table to simplify this. 3 4s are 12, 3 9s are 27. So boys and girls, after simplifying this, we found that 9 upon 4 is equals to 6 upon d, the whole square. Now we need to get rid of this square on the right hand side. For this, what we will do, we're going to take square root both the sides. So square root on this side, square root on this side, square root, they cancel out each other. The square root of 9 is 3. The square root of 4 is 2. So you have 6 upon d. Still d is unknown. Cross multiply the two denominators on either side. 3 multiplied by d and 6 multiplied by 2 is 12. D is equals to 12 divided by 3, and 3 ones are 3, 3 fours are 12. D is equals to 4 centimeters. I hope this makes sense to you guys. Okay, again we have used the same formula and we found the unknown length L2 by plugging in the values in the formula and simplifying it, cross multiplying the two denominators on either side, and we found D is equals to 4 centimeters. So the next question, boys and girls, finding length of the similar figures. Now again, this is an example. Let's solve for you. The next question will solve it on our own. Okay. In the figure, QR is parallel to XY, PQ is 6 centimeters, and the area of triangle PQR and PXY are 9 centimeters square and 64 centimeters square respectively. Find the length QX. Find the length QX. This is this length in this figure. QX is this length which they are asking us. Alright. Now, QR and XY are parallel and the parallel lines are indicated by arrows. They have given us PQ as 6 centimeters and the area of PQR and PXY are 9 centimeters and 64 centimeters square. Find the unknown length QX. So the same formula is used, right? That is A1 upon A2. A1 is the triangle PQR. Triangle PQR is the first upper triangle, and this big triangle, boys and girls, this is PXY, triangle PXY. Now you have got two similar triangles, the big triangle and the small triangle. So you'll apply the same formula. This is A1, this is A2, this is L1, and this is L2. Alright, boys and girls, A1 upon A2 is equals to L1 upon L2 the whole square. A1 is given to you as 64, A2 is given to you as 9, Px square upon PQ length is given to you as 6 centimeters. Here it is, so you have kept it. Now you can see that there is a square on the left hand side, and on the right hand side the numbers 64 and 9 are also perfect square. So you need to take the square root. You can take the square root on the two sides, or you can open up the bracket. This is up to you. In this case, they have opened it px whole square and 36. Now you can cross multiply this on the other side. 64 multiplied by this, 9 ones are 9, 9 fours are 36. 4 multiplied by 64 is px square is equal to 256. So by taking the square root on the two sides, you found that the square root of 256 is 16 centimeters. Now, px is the complete length, 16 centimeters. This complete length they are talking about. Now, what is the question? Find the length qx. So, what they have done, qx, the complete length qx is equal to px plus pq. Plug in these values that have been given to you. Px is 16. Px as 16, we just found it out, Px is equal to 16. So plug in this value, Px is equal to 16, and Pq. Pq is this length given to you in the figure. So 16 minus 6 is equals to 10, is equals to 10 centimeters. That's the answer. So let's do one question on our own. Question number 7. A triangular plot of land PQR is such that PT is 6 meters and PR is 10 meters. ST and QR are two water pipes that are parallel to each other. The area of triangle PST is 24 meter square. Find the area of PQR. So boys and girls, the first thing is that they have given you area of the first small triangle PST as 24. A1 is equals to 24 meter square. Now what is required? The area of the big triangle PQR. So what is the formula? A1 upon A2 is equals to L1 upon L2 the whole square. So the area A1 is 24, A2 is unknown, let it be unknown. L1 is the length of the first triangle PQPST. So this length PT is given to you as 6 meters, and the bigger length PR is given to you as 10 meters, the whole square. 2 threes are 6, 2 fives are 10. So you can open up 24 upon A2 equals 3 threes are 9, 5 fives are 25. So furthermore, you can simplify it by cross multiplying the denominators on either sides. 24 multiplied by 25 divided by 9 is equals to A2. So you can simplify it. 9 ones are 9, or 3 threes are 9, 3 eights are 24. Finally, you have 8 multiplied by 25 is 200, and the denominator is 3. 200 upon 3. Now, you can simplify it by using your calculator. It will be something 66.6666. So you have A2 is equals to 66.7 centimeters square, or meters square, sorry, 66.7 meters square. So boys and girls, we found the area of this big triangle, that is A2 is equal to 66.7 meters square. Now what is the other part of this question? Find out the land occupied by SQRT. SQRT is this land. They're asking you find out the area of this. Or in other words, find out the area of the shaded part. The shaded part is trapezium SQRT. What can you do? You can apply the concept of finding areas of the shaded parts by subtracting the two similar figures. Now that is triangle PQR minus triangle PST. This will give you the area of the trapezium SQRT. Excuse me. So I'm doing it here. Part 2. Area of SQRT is equals to the big area of the big triangle, 66.7 minus 24. Furthermore, you can simplify it. 6 minus 2 is 4. 6 minus 4 is 2. 42.7 it's meters, sorry. It's not centimeters, it's only meters. Meters square. So this is how you find the unknowns by applying the same formula. A1 upon A2 is equals to L1 upon L2, the whole square. So let's move on to the next question and see what is next. All right, boys and girls, this is another question number 8. In the figure, HG is parallel to QR, GF is parallel to PQ, and QF ratio FR is P ratio Q. Find the ratio of area of the triangle PHG to that of triangle PQR in terms of P and Q. Now what is P and Q? If you read this very carefully, QF ratio FR is P is to Q. This is P and this is Q. right? Now, as this is I'm talking about this figure. This is a parallelogram, so this will also be P, right? Now, what are they asking us? Find the ratio of areas of triangle PHG to that of triangle PQR. So, the first thing you need to identify the pair of similar triangles. The pair of similar triangles, as they've also mentioned it in the question, triangle PHG and triangle PQR, they are similar. So you can write down the formula: area of triangle PHG upon area of triangle PQR, that is A1 upon A2 is equals to L1 upon L2. What is L1 is HG, and what is L2 is QR, and this has to be the whole square. The ratio of areas of the two similar figures equals to the ratio of their area of their corresponding sides, right? Square of the ratio of the corresponding sides. So we can simplify this. Now, if we see that HG is P and QR is P plus Q. This is P and Q. The bottom line of this triangle QR, it's a sum of P and Q. So we can plug in these values equals to HG is P and QR is P plus Q, the whole square. This is triangle PHG and this is triangle PQR. Now, what's the question? Find the ratio of areas PHG to that of triangle PQR in terms of P and Q. So here it is, boys and girls, in terms on, or we can try out and open up the bracket, is equals to triangle area PHG upon triangle PQR is equals to P square upon P plus Q the whole square. This is also correct. Now, hope this makes sense to you guys. What we have done, we have applied a simple formula. The ratio of areas of the two similar figures equals to the square of the ratio of their corresponding lengths, and we plug in these values, open up the brackets, and finally we find out that P area of the triangle PHG upon area of the triangle PQR is equal to P square upon P plus Q the whole square. This is the required answer in terms of P and Q. Now, boys and girls, hope you have learned this. It's very simple. The entire exercise is based on the same formula. So what did we learn today? We learned today the ratio of areas of the two similar figures is the square of the ratio of their corresponding lengths. That is A1 upon A2 equals square of the ratio of their corresponding lengths, L1 upon L2, the whole square. Now, thank you so much, students. Now attempt the practice now 1 and 2 questions right after this lesson for a better understanding. You all are advised to leave a response. Take a good care of yourself. Have a nice day. See you all again tomorrow. Until then, Allah Hafiz. Bye bye.